Okay, class, this is CSE 312, CSE 504. It's a joint course, an undergrad course and graduate course, scientific preparation course. So there will be two type of students in this classroom. Most of you will be from this course, CSE 312. This is about operating system. And these slides are about how we are gonna do these lectures and how we are gonna grade this course and other kind of details before we start the technical details of the course. Okay, so let's start. My name is Yusuf Akgül. This is my email address and my phone number. This is the internal number for the university. If you like to reach me, just send me an email. If you don't answer it in a day, just send me another one. If you don't answer it in another day, send another one, etc. It goes that way. I'm usually very busy, so don't try to ask me emails about very simple stuff. Instead, we have a teaching assistant for that, TA. His name is Muhammad Ali Dede. Maybe some of you know it. His office is just upstairs in the vision laboratory. So any questions about the course, any details, you just ask him first, and if he cannot answer, ask him to ask me the question. Okay, don't come to me immediately. Ask him to ask me the question, and we will resolve the issue with him, because there might be several of you asking the same question. So he will have all the questions, and if he can answer, he will answer. Otherwise, he will come back to me, and we will make a decision, and he will let you know about the question. Okay, so this is the one of the basic rules of the course. Okay, so this year I am not sure about this, but is the Moodle page open? Did you check it? It's not open. It is down. No Moodle pages. Because the Salih, senin OS dersi şeyin sınavın çarşamba 13'te, tamam mı? Unutmadan. Eğer unutursan videoyu da kaydettim, dön oradan izle şu an. Bir şey yok, geç otur tamam. So I am not sure. The faculty of engineering, I think they have a nice system. They are starting it. They call it ödev kutusu or something. I don't know. Ders kutusu. So we have to translate it to English too. We might use it, but usually the first time they start using it, they start using something. It doesn't work very well. That was the case for the Apollo. It still doesn't work very well. So we might for this semester we might still go on with this Moodle system. So we will resolve this issue today or tomorrow, or at least this week. Okay. So either this system or it will be a system from engineering faculty. Engineering, okay. I think it's called ders kutusu. I don't know. Did you see the announcement for this one? Ders kutusu? No. Okay, we will let you know. Okay, we will let you know at least on Friday's lecture. Okay. How about this one? This one is doing well. Okay, yeah, good. So we will follow this textbook, required textbook. The textbook is required. You are supposed to buy it or find some kind of a copy of it. Buy it from last year's students. Get it somewhere. Okay, you have to have this one book. And I think, as far as I know, the book is available at Çağlayan Store. It used to be like 120 Turkish liras last year, but this year it should be around
60.
What?
150, 160 maybe.
Maybe you are guessing it?
Yes.
I can guess it too. So let me guess, it is 160. but I don't know the price. Okay, usually what you guess is lower than the actual price. So let's say it is around 200 liras. And it's too much money, I know. You don't have to buy the original. And find some kind of a solution. I don't know what that solution is. I will try to put the slides of the book at the Moodle page, but the slides will be only the figures from the book. Okay, the slides will not be same as my slides because I keep updating these slides. And so you are supposed to buy the book and read the book and study from the book. Don't try to get away not buying the book and reading it from the slides and studying it from the slides. That will not be enough. So buy the book. As I said, I will not make my slides available. Of course, I will try to record all the classes on video and post it on YouTube, like I am doing right now. I'm live streaming my lecture right now. But can I live stream it outside? Maybe I can, right? There is a monitor outside, and let me see if I can do that. I will do it during the... Okay, I will do it later. So the YouTube videos will be available there too, yeah, but I will say from time to time, read it from the book and details are in the book and etc. So the book is important. Buy the book or get some kind of a copy, second-hand copy or that kind of copy. Okay, any questions? For this course, you need solid C++ Java programming skills. Okay, you need to know C language very well. Actually, you need to know C++ and Java language very well. Officially, these are the prerequisites for this course. Okay, this is C programming and this is computer organization courses. This is for doing the programming homeworks, and this is for understanding what, because the operating system works this way. Operating system, first of all, operating system is a piece of software. Well, it's a large piece of software, but still it's a piece of software, and it works this way. At the, what's going on? My battery is out. That's what happens at the beginning of the semester. Something doesn't work. Oh, okay. So at the bottom you have your hardware. With this hardware you have your CPU, hard drives, I/O units, and etc. On top of the hardware, your operating system is running. Operating system is a piece of software, as I said. Maybe it is a very complicated one. Maybe it is like 60 million lines of code. It might be very complicated or very simple operating system, but it's a piece of software. Okay. To understand this operating system, okay, as the designers of this operating system, I should know sufficient programming, C++, Java programming, because we will do our homework using object-oriented programming languages. Okay. The other thing is that this piece of code works on top of this hardware, and there are no abstraction layers between them. So this software should know its hardware very well. Okay, that's why you should be you should know about this course, and this course is for hardware and this course is for software. Okay, so if you do not satisfy these conditions, please talk to me. If you are the undergraduate student, okay. If you are a graduate student, yeah, I know you may not have taken these courses. You don't have to talk to me, but your job is a little bit difficult than the undergraduate students' jobs, because it will be your effort to catch up with the other people in the course. But you are a graduate course, you should work much harder anyway. But if you are an undergrad course, undergrad student, you should satisfy at least these two prerequisites. And if you don't satisfy that, then officially you should not take this course. If you take this course without getting a passing degree from these two courses, then that means that you cannot take this course officially. Even you take it somehow, I don't know, this Apollo system doesn't work very well. It lets you take it sometimes. You should drop it immediately. You should drop this course. If you don't drop it, and if you later we realize it that you didn't take these prerequisites, these two, we will drop your course automatically. It doesn't matter if you have taken the final, if you have completed all the homeworks, because officially these are the prerequisites. Okay, so this is important, prerequisites. Understand this very well. Any questions? So as a rule of thumb, every slide or every other slide, every 2 slides, I am expecting you to ask me a question. If you don't ask me a question, and if the class is too quiet, then I will wait until you ask a question. If nobody asks a question, I will make one of you to ask me a question, and I think we are coming to that in a short while. Homeworks. We are going to use GNU compilers and standard Java compilers to compile your code, and we are going to provide a virtual machine. It is going to be a Linux machine, a virtual machine, so everything has to be compiled and run on this machine. If your code doesn't work on this virtual machine, then your homework will not get graded. Okay, so this is standard machine, and this way, since it's a virtual machine, we will not have any compatibility issues. Okay, and you will not use any other development environments for the demos. If we have any demos, you're gonna run your program on the command line, and you are gonna show us your results. Or when we run your programs, we are gonna run your programs on the command line. We will not use any development environments to compile your code or run it or etc. Okay. For the homeworks, you will strictly follow the homework instructions, etc. In the homeworks, it says that do this and this, and don't do that, this and that and that. And especially with the due dates, your submission times and submission rules, etc., etc., you should follow the homework instructions. And these instructions will be available in the homework text. Okay, any questions? Grading will be tentatively, approximately like this. Midterm exam 30%, homeworks projects 30%, and final is 40%. I will list all of your grades and calculate your overall grade, and I will assign you your letter grades by looking at who is doing best and who is doing worse, and etc. These are not all the rules. There are some other rules for the grading. Okay, for example, if you submit less than 75% of the homeworks, you will get a grade of NA from this class. So we are expecting to have 4 to 5 homeworks. Okay, one will be about general introduction, the other one will be about processes and threads, the other one will be about inter-process communication, and the one will be about memory, and the final one will be about input output or the file systems. Okay, so there will be 4 to 5 homeworks. So let's say if it is 4, that means that if you miss one of the homeworks, you might be okay, but if you missed 2, then you will get an NA from this course. Okay, and the due dates will be on the homeworks, and if you submit your homework late, 10% of the maximum grade will be deducted for each day late. Okay, and it doesn't matter if it is 1 minute late or 30 seconds late or what. Sure, if you take this course, yes. As I said, 10% of the maximum grade will be deducted. Doesn't matter 30 seconds late or 23 hours 59 minutes late, it will be 10% off since it's a day. If your homework is late more than 5 days, then we will not accept your homework. Okay, that doesn't mean that you should not do the homework. Of course you should do it, because the homeworks will depend on each other. The first homework is the most important. It might be the simplest, but it will be the most important. The second homework, third homework, and it will be related to each other. So even if you don't submit your homework, you should still do it. Otherwise, you won't be able to complete the other homework. By the way, if you submit a junk homework, that means that homework doesn't have anything to do with the homework that I assigned. We will not grade your homework. Okay, it should be something meaningful. You should try to achieve something. Okay, if you have some situation that prohibits you from turning in your homework on time, just talk to me or talk to the TA. It might be a family emergency or personal emergency, medical situation, whatever it is. Okay, if your excuse is excusable, then we will try to work out something. And excusable things are usually medical stuff, like you are sick or your family is sick or some other emergency. But if you like to attend your best friend's birthday party and that kind of stuff, those are not. It might be good excuses for you, but not for me, because your friend is not my friend, and I already attend my best friend's birthday. Anyway, okay, exams. April 1st. It's not a joke. It's the exam date. I think it's on Monday, right? April 1st. It is the 8th week of the semester, I guess. Let me see. So this is.
After the elections.
So this is 1, 2, 3 this month, and 4, 5, 6, 7. Yeah, April 1st, Monday. We may not have enough space during the lecture time to have the exam during the lecture time, so we may have to do it. We may have to do it after the official hours. That means maybe your exam might start at 5 p.m. Okay, I don't know. Maybe I mean sometimes even 5 p.m. may not be available. In that case, we may do your exam during the weekends. Okay, we are not sure, so that's why it is tentative, but it will be on that date. Okay, and the final exam will be the second week of the exam period, final exam period, and it will be during the class time. Okay, so these are the rules for the exams. Attendance is part of the class. I have to take the attendance by the rules of the university. Attendance is required, and attendance will be taken regularly. No exceptions for this rule. Okay, so I will take the attendance unless you have taken this course before and you have taken a grade of at least FF. Okay, unless you have failed this course before. Even for those students, you should come to the class and ask your questions and try to understand what we are saying. And you are responsible from all the subjects that we cover in the class. Some of the subjects may not have been covered in last year, so we don't usually when you say we didn't see this last year, when you say okay, last year you teach this one and you are teaching this one now, I mean it is up to us to change the course material. So this year is a brand new year. Whatever we are teaching this year, you are responsible from everything. Okay, and if you don't attend more than 70% of the classes, or if you miss more than 30% of the classes, then you will get a grade of NA from this course. So if you are wondering, there are two ways to get an NA from this course. One is this one: miss more than 70% of the 30% of the classes, and the second one is miss more than more than one homeworks in this course, if you like to know. But I don't encourage you to test us on that issue. We are not afraid to assign this grade. If you don't satisfy these rules, there are no exceptions. You will get a grade of NA. Unfortunately, many people get this grade because they don't do the homeworks. Okay, homeworks are important. Because if you start reading the book is very nice. It's like a novel. You read it, it is very readable, very fluent. You just read it chapter after the chapter. So if you try to read the book and if you try to follow the lectures, yeah, you will be fine. But if you don't do the homeworks, you really don't understand what's going on with the operating systems. Okay, so try to do the homeworks not for the sake of getting a CC from this course. Try to do the homework, spend time, spend at least 4 or 5 days, full days, okay? Try to understand what we are trying to do, what we are trying to give you as a message with that homework, okay? And try to find parallels between your homework and the real operating system, and try to ask questions on during the lectures about the homeworks. Okay, any questions? Homework submissions announcements. All the class related announcements will be made either in the class or in the class Moodle page or the new system, whatever that is. Okay, so if you don't come to the classes and if I do an announcement and if you miss it, you are gonna miss it. You are responsible from all the things that I said in the class. Okay, and you are required to read your emails regularly, and you check your Moodle page or that new page that the faculty is going to give you, engineering faculty. Okay, and the homeworks will be announced at the Moodle page or the other page should be the. Okay, and you will submit your homeworks at that page too. Okay, sometimes we have issues with that page, Moodle page, like the page is down and etc, and the due date is during a weekend. Sometimes we may not fix it on time, so for those kind of cases we are gonna give you like 4 or 5 hours of extension or 1 day of extension because system was down. Okay, so honor code, you are not supposed to use somebody else's work as your work. If I assign you an homework, it should be 100% your code. It should be 100% your work. You should not copy even a single line of code, single line of text from somebody, from one of the other members of the class, or from an online source, or from your last year's, even from your last year's code. Okay. Because that code was maybe written for you. That code might be written by you for last year's course, but it is still you are supposed to complete this course for this year's requirements. So everything should be original, everything should be written by yourself. Don't try to get anything from somewhere else. Okay, and all cases of confirmed cheating will be reported for disciplinary action. I don't want to discuss this too much, but we have our ways of dealing with this, and we don't like this. I don't want to talk about this slide much, but it happens all the time. Sometimes some people do that kind of stuff, and we have our ways of dealing with this stuff. And if you don't be in this situation, then both of us, you and I, will be happy. But if you are in this situation, we will take care of that situation, and that will not be very nice. It will be nasty. Okay, topics to be covered. It's very simple. General introduction. This chapter will be very important because it talks about everything about all the operating system concepts. But since it's an introduction, it doesn't give you the details. Then we will talk about processes and threads. You have taken you are taking your systems programming course this semester, right? So that course is kind of a laboratory for this course. So we will be talking about the same things. That course is more practical. It will talk about libraries. It will talk about using those libraries and producing some runnable code. We will talk about how to write those libraries. Okay, so systems programming uses the libraries provided by the operating system. Operating system course tries to tell you how to write those kind of libraries. So that's the difference. So they kind of complete each other very nicely. So the first task will be process and threads, but that course is kind of delaying this discussion into the second part of the semester. But these two topics will take at least 5 or 6 weeks, so it will take lots of time. Then we will talk about memory, then file system, then input output. Deadlock, I may not talk about that much. I will try to spend more time. with this last two topics, virtualization and clouds and security. Deadlocks are, well, they are discussed very often with the operating system courses, but I don't like them for some reason because nobody uses them. Okay, this is more important. So that's it. After that, the course will be over, and hopefully you will have enough understanding for a computer engineer to be knowledgeable about operating system as a designer and as user. Okay. So we will talk about this these 2 point of views very much. As a user of the operating system, we have to understand it. As a designer of the operating system, we have to understand it too. Do we think that we are going to design operating systems? Sometimes yes we do. Some of our graduated students, they work on operating systems, simple operating systems, real-time operating systems, embedded operating systems. Maybe some of the graduates, how many graduate students are there in this one? Are any of you working on real-time embedded operating systems? You are working. What are you doing?
I am working on developing software on onboard computers of satellites.
Are you contributing any code to the operating system side, or you are writing on top of it?
I'm taking on top of them.
On top of it, but usually you know what's going on with the operating system because the embedded operating systems are more simpler or more open, and it is very easy to make mistakes when you program them. So sometimes you write code for the operating system. Sometimes you write drivers. Do you write drivers? I mean, if you write the drivers, if you write a driver for a device, then that means that you are writing operating system code. Okay, it is very easy to crash that operating system by making a mistake in your driver code, and you need to understand how the general concepts of the operating system work. So this is the first point of view as a designer, as a developer for the operating system. The second point of view is as a system programmer. You write your code on top of the operating system. You have to understand why some of the solutions might be too slow, too dangerous, too inefficient, etc. That's why you need to know how the operating system works. And the third thing is that, what did I say? Operating systems are they are software, right? They are software. They might be complicated, so that means that for the whole semester we are going to study a complicated piece of code written by very smart people, very good computer scientists, and we are going to have good opportunities to understand how these kind of systems are designed and how these kind of systems are implemented. Okay, so we will have our opportunity as software engineers to study one large software. Okay. Yes.
Hocam miktarda nereye gelmiş olacağız şimdi?
All the questions will be asked in Turkish and I will answer them in Turkish. So what is your question?
Midterm'de nereye kadar konu olarak gelmeyi bekliyorsunuz?
All the questions will be asked in English. Did I say Turkish?
Yes.
Okay. Since I said Turkish, that you ask in Turkish this time, okay? Bu sefer Türkçe sor madem öyle dedin.
Hocam.
Sor. Midterm'de
Nerede olacağız?
cevabını bilmiyorum. Nerede olursak 6. haftada. So I am changing the rules. All the questions will be asked in English and all the questions will be answered in English, okay? Try to ask questions you're in English. You see, my English is not good, okay? I make lots of mistakes. I use lots of words wrong, but that doesn't stop me talking, right? From talking. You just do the same thing, okay? Nobody will laugh at you. If somebody laughs at you, makes fun of you, that his or her problem, okay? It's not your problem. But if you have a question, if you don't ask it, that's your problem, because you're gonna fail from this course, or you're gonna fail from somewhere, or if you don't, even if you don't fail, you're gonna miss an opportunity. I know stuff, okay? I read that book maybe 2 or 3 times. I read lots of other operating system books, okay? I know about the operating system more than most of you. Some of you might know better than me. I am not arguing that I am the best, okay? So if you ask questions, you will have good chances of knowing something from me, okay? If you don't ask me any questions, I will say that, okay, they are fine, they are not asking questions, they understand it, and etc. So And make this as a rule. You are going to ask at least one question or one question a week. So at the end of the semester, you will have lots of questions asked, and you will get over with your phobia of asking questions in public, etc., in Turkish or in English. And that's because when you go to job interviews, they will start talking to you in English, and you will have only 3 minutes of time. Okay. So if you are not answering any questions in English, or if you are not asking questions in English, you will have a very, very bad mark from your interview, and you will not get that kind of jobs that require you to speak in English and answer in English. It's not a difficult thing, okay? Everybody does it. Even 2-year-old American children or English children can talk English, so you can do it. You can do that too, okay? So I think that's it for the introduction. How about our time? This year my eyes are gone. Without glasses I cannot read anything. Okay, so I will start the course now. If you don't have any questions, where is my attendance? Okay, here's my attendance. Let me see how many people. So did everybody? Ahmet Burak Karkaç. You didn't have your name in there? Okay. What kind of sort is this? How did they sort it? So your number is 08. Okay, fix that problem. I don't know what your problem is. And I have 2 graduate students. They didn't. Okay. Okay. So it is your responsibility to get registered to the course. I don't have anything to do with it. But if I don't see your name on the list, I cannot give you assign you a grade. So fix that problem first. Okay, that's it. Okay. By the way, signing this attendance sheet for somebody else is a serious thing. If I catch somebody doing that will not be a very nice situation. Okay, time to time I will check it. For example, let me check it. Yusuf Aktaş, Yusuf, Can Dursun Terek, Hasna Merve Nur, Salih Bektaş, Soner Akar, Ömer Bozaba, Ömer, Burhan Ergün. Okay, so I will do this time to time, and if I find somebody not here but sign is there, that person will get an NA, and if I find whoever did that person will get NA too. So you will get 2 NAs. Okay, these are not threads. Okay, I mean this is a very large course, 121 people plus 20 people, 140 people. We have to take these kind of cautions. Okay, if there are no questions, then I will start my operating system discussion.
Professor,
Yes.
I have heard some complaints from last year's students from your last course, and towards end courses, towards final homeworks, with empty assembly files, you make them pass without waiting, without checking. So I'm saying this because we are talking about key pillars of the course now.
Okay.
I
You mean the homeworks?
I request you to.
You mean the homeworks?
Yeah, I mean homeworks. I request you to highly, equally behave us about our rights without walking over them, please. I know.
What do you mean without walking over?
Checking homeworks has nothing.
You mean
to do
that
with
people have passed without writing any homeworks, without assigning any homeworks?
No, they assign empty bodies. Just
And they
sample
passed?
files, yes. DD or DC.
Well, that's a very serious mistake, because I mean TA grades TA is the same. It was Muhammad Ali. It was Muhammad Ali. And if it is the case, then that's a very serious problem. And I wonder why you have waited until next year to give me this news. I mean, you could have come to me and told me that this and this happened. Are you telling me this right now because you have failed? if you passed it, you didn't tell me anything about, you wouldn't tell me about anything about it, right? If you make a mistake and if you see that that's hurting you in terms of what you are learning, you should immediately tell me, okay? If you wait 1 year and if you tell me after a year, this is my right and you are not doing it right, and I don't bite much, because you are just telling it that you didn't get the CC, right? That's what you are saying. Don't talk about your rights, okay? Your right is to learn something here, okay? You missed it, okay? If you have gotten the CC, you wouldn't say anything about this to me, so you don't have the right to talk about rights. But that's a very serious mistake on our part. If somebody like that, without assigning a meaningful homework, got a passing degree, then that's not good. I mean, that's not. I mean, of course, I didn't lose anything. I'm doing the same thing. But that person lost lots of stuff.
I know it has nothing to do with you, but just.
Well, this course is my responsibility, and that's my mistake too. Because I mean, I cannot say that was a TA and TA didn't know. This is. Whatever I am assigning as a grade to you, it's my responsibility and it's my mistake. And I will try to go back and see, do you have the names?
Yeah, I have, but I will not say.
Okay, maybe we can go back to the Moodle page and find those kind of stuff, and we can always fix stuff. I can find those persons. I don't know. Or I will talk to the TA and see why it happened and try to work on it so that it doesn't happen again, okay? And maybe change the TA or something, I don't know. Okay, thanks for letting me know. But as I said, don't talk about your rights. I mean, you're not telling me this because of your rights. You are telling me because you have failed. Okay, any other questions? Thanks for the question again. Okay, let me start talking about operating systems. This is chapter 1 and the first chapter. Why study operating systems? Usually, I mean, the beginning of the book, all the operating systems book, and the first chapter, they try to talk about what is an operating system. If somebody talks about if somebody talks about the definition of something a lot, that means that there is a problem with the definition, okay? We don't talk about the definitions of the programming languages. When we start talking about C programming languages, they say that, okay, this is the language, this is the compiler, you compile and you run it, that's it. But with the operating system, we say that, okay, this is the definition of operating system, that's not operating system, this is operating system. If there is no operating system, this happens. If there is no, that means that there is an issue with the operating system. That's why some people say that operating systems are like magic. Okay? Operating systems are magic. Why? Because most people don't understand them, including the system administrators, computer scientists, university professors, computer engineers, etc. To understand them very well, you need to know about the theory of the operating systems, history of the operating systems. Also, you need to have some operating system coding. Okay, so this is one thing. They are very, very complex. Okay, for example, when you say a simple C program that writes hello world on the screen, when you compile this program, usually you use lots of libraries in it, right? The combination of those libraries to be able to compile and run this simple program, the number of lines for that one will be 1 million lines of code. So you are using very complex structure of software, and even the simplest program needs this kind of code, okay, underneath. You don't realize it because that complexity is abstracted away from you, okay? But if we didn't have the operating system, if you don't have the concept of layering your software, what did I say? At the bottom, I have my hardware. On top of it, I have my operating system. On top of it, I have my libraries. On top of it, I have my programs, okay? So most of the time, as a programmers, we work on this layer, okay? As a programmer, I write my programs. I use the C libraries, C++ libraries, Boost libraries, etc. And my programs and my libraries use the operating system routines. They are again software, and operating system has the exclusive usage of the hardware. So to be able to write a simple program, if I need to know all the details of the libraries and the operating system and the hardware, that means that only a handful of people could have written programs in this world. But we need millions of programmers. So this is what we do. We simplify stuff. We make everything abstracted from these 3 layers. And for the programmers, we say that all you are going to do is you just call printf or the cout object. Okay. So if every application programmer had to understand how these things work, no code would have ever get written. It would be very, very expensive. That's why at the beginning in 1940s, you didn't have any of these. Okay, you only had the hardware. If you are writing a program, okay, there was no keyboard, there was no screen. You were modifying your hardware. So and the computers were very, very expensive. They were maybe like $10 million or $50 million computers. You get your computer. It's a very large room, okay, as large as maybe this building. You go in that building and the computer is yours for a day, and you modify your hardware and you make your calculations, and at the end you have to finish your job and come back, and you have to be very knowledgeable about the hardware, very knowledgeable about the algorithms, very knowledgeable about the how the overall system works. So not many people knew this. That's why it was very, very difficult to use the computers in those days. But later, when they realized that this is not working, they invented these kind of operating systems and their libraries, etc. So with the operating systems, this is what we get. Okay, we get the abstraction. Instead of knowing all the details about the hardware and the library and etc., we have abstraction mechanisms. We say that this function, this library call, this function or this library call does this and this. You don't have to know the details. I am hiding them away from you. Principle of information hiding. And you are a customer and you're gonna use it. Okay. So with the studying of the operating system, we are going to deal with this complexity with the abstractions and the modularity. There will be many, many modules. For example, for this operating system, when we say operating system is not a single box. Okay, it has many layers in it, and it has some boxes. What kind of layers? For example, I have the CPU abstraction layer. Then I have memory abstraction layer. Then I have, for example, networking software. Then maybe I have some other input-output software. Maybe some stuff drivers. Maybe some file system. Okay. So operating system is structured this way too, because they are very, very, very complex. Okay, they are very, very complex. So modularity is very important. And iteration is, again, with any other software, you cannot write 60 million lines of code or 80 million lines of code in a single night. Okay, you have to do iterations. Okay, and we have been doing the iterations on the operating system since 1950s. Okay, 1950s. It has been like 60 years. Or 65 years that we started writing operating systems, and every iteration we try to fix something. Okay, I mean, maybe 20 years ago the most important problem was the stability of the operating system. Like, it should be stable, it should not crash. And maybe 20 years ago your operating system crashes every day or every other hour. So it was very, very difficult to write systems, write programs, or write reliable programs to run on businesses. Nowadays our problems more like it should be efficient, it shouldn't take too much battery power, because instead of using these kind of computers, now we are using Where is my other computer? Yeah, now we are using these kind of computers, and for these kind of computers, battery the power usage is very important. It should be stable again, but it should be secure too, because the information is with the very popular usage of the internet and wireless networks. Everybody can access to everybody else's computer, so that we should keep our information safe. Safety, information safety is important. Nowadays we are talking more about this kind of situation. That's why I said that I like to spend more time on virtualization and the operating system security a lot. Operating system security was not that important for the PC operating systems like in 1990s. Well, it was important, but we didn't have the power to enforce it. That's why most of the operating systems, they were very, very easy to hack. Okay, so with the iteration, every time we will try to solve something new. Okay, so these are some of the reasons why we are studying operating system. Okay, so as I said, there are many ways to look at operating system. One of them is why we are studying it. The other one is what is an operating system. Okay, so this is important. There is a very good discussion in the book. Read it. And this is what is an operating system. Okay, operating system is this. Okay, as I said, is a software. This is, never forget about this. It's a software. Okay, but it's a complicated piece of software. It abstracts the computer hardware through interfaces. Without the operating system, I need to know all the details about my hardware, okay? But with the operating system, I don't have to know about the hardware. All I say is that save this file. Where am I saving it? I don't care. How am I saving it? I don't care. What are the physical devices that I need to manipulate to save it? I don't care. All I say is that save this file, save this information. So all of that hardware is abstracted from me by the operating system. It hides messy details of the underlying hardware. Okay, those details are messy. Okay, and it presents the users with resource abstraction. That's easy to use. It hides them, but it also makes them easy to use. As I said, saving a file to a disk or USB drive or to a network drive or wherever you are saving it is very easy, because all you say is that save it. Okay, open the file, write it into it, and close it. That's it. Okay, and it extends or virtualizes the underlying machine. Okay, can anybody tell me what this means? Extending or virtualizing the underlying machine. Extending the underlying machine. Picture is this. Underlying machine is this. And I have my operating system in here. Okay. How does the operating system extends the hardware? Yes.
It creates virtual memory.
For example, it creates the virtual memory. What do we mean by that? For example, if say in my hardware, let's say I have 1 gigabytes of memory. Okay, if I have 1 gigabyte of memory, my operating system has ways of showing me that in fact I have 1 terabyte of memory. Even though I have 1 gigabyte, my operating system could tell me that, okay, you have 1 terabyte of memory. So how does the operating system does it? Okay, I have lots of missing memories. Where do I get them? Operating system uses this memory in a way that if I need extra memory other than this 1 gigabyte, it uses the disk space. So it swaps memory from the disk back and forth. Okay, since I have my disk, okay, and I have my, let's say this is my memory, this is my disk. So it moves information back and forth between my disk and the memory, so that as a user, I think that I have 1 terabyte of memory. Okay, this is virtual memory. This is called virtual memory, and this will be our second most important discussion in this course. The most important is, but not memory, but it's something else. And again, it uses the virtualization too. How do you extend? Okay, I extended the memory this way with the virtualization. there is something more important than memory, or as important as the memory with the hardware. What do we have with the hardware? Yes.
Çok kısa bölebilir miyim?
Sure.
Bu tutorlarla ilgili.
Okay, we have an announcement for the bir tutorlarla ilgili duyurumuz var arkadaşlar.
Arkadaşlar,
Hoca İngilizce konuşamıyor da.
bu bizim 102 ve 108 derslerini biliyorsunuz. C ve C programlama ve C programlama dersi için tutora ihtiyacımız var. Tutorların görevlerini genelde siz biliyordursunuz. Geçen o dersi aldınız büyük ihtimalle. İnsentif olarak bu derste sanırım Yusuf Hoca
CB ve üzeri not alanların bir harf yapıyor. CB'lerini BB, BB'lerini BA, BA'larını A yapıyoruz.
evet, bir harf notu yükseltiyoruz.
A alanında da çay ısmarlıyorum ben.
A alanda başka dersler kullanıyor. Sonradan geliyor. Hocam öbür derste kullanabilir miyiz diyor. O tabii bir insentifimiz var.
Bir dakika onu söz
Onu
vermedim.
söz vermedim.
Yani biraz şaka olarak
Siz
söyledim.
eğer tutörlük yapmak isteyenler varsa dersin asistanı Burak Hoca. Burak'la görüşün. Hangi ders için notunuzu yükseltmek istediğinizi de söyleyin. Mesela bu ders için yükseltmek istiyorsanız bu ders olduğunu söyleyin. Dersin lablar pazartesi günleri saat 1 ve 4-5 arası 2 session oluyor. Bir session'da görev almanızı bekliyoruz. Aynı şekilde 102 dersi için de ofis ağırları olacak. Ofis ağırlarını da biraz esnek yapacağız bu sene. Onları düşünebilirsiniz. İlgi bekliyoruz sizden. Hem şey açısından sizin için ders için bir insentifiniz var. Bir de öğrenmenin en iyi yöntemlerinden bir tanesi, biraz daha iyi öğrenmenin en iyi yöntemlerinden bir tanesi iyi bir şey olabilir. Nasıl diyelim? Tecrübe olabilir. Bir de daha sonradan benden referans almak isterseniz onu da kullanabilirsiniz. Almak isterseniz bilmiyorum ama belli olmaz. Evet.
Daha önce C'den almamız gereken
Evet.
bir not var mı?
C++ veya Data Structures dersinden en az BB almış olmanızı bekliyoruz. Bir tanesinden BB almış olmanız yeterli. Hepsinde değil. Bir tanesinden BB almış olmanız bizim için yeterli olur.
İsterdiniz ama
Siz yine de gelin.
Sistem programı C sonuçta.
Neyse siz yani CB olanlar da gelsinler. Size listemizi alırız. Olmaz. Yedek listemizi alırız. Arkadaşlar bu önemli bir konu. Gerçekten tutorlar biliyorsunuz çok faydalı oluyor derslerde. Siz de faydalanmıştırsınız büyük ihtimalle zamanında. Katılımınızı bekliyoruz. İnsentifi de kullanmanızı bekliyoruz. Var mı başka soru? Evet. Mehmet Burak Koca bizim dersin asistanı. Eğer onu bulamazsanız bana da gelebilirsiniz. Tamam. Çok teşekkürler ilginiz için. İyi dersler.
Okay, I think it is time to take a break, right? Let's take 10 minutes of break. After break, we will continue from here. Right.
Hocam biz de geç geldik de oradan geçirsiniz artık.
Olmaz.
Neden?
Çünkü 5 dakika geç geldim.
Ama buraya otursaydım atabiliyordum.
Ama o zaman buraya oturabilmek için erken geldim.
Ama 5 geçe geldim.
Vision var ya.
Ya zamanında girin ya. Atın bir daha zamanında girin.
Teşekkürler hocam, sağ olun.
Siz bu dersi ilk defa mı alıyorsunuz?
Evet.
Çarşamba yok
Ben geçebilirim.
Sen söyledin mi abla? İyice çevirecekler.
Tamam, yani Cuma günü bir şey yaptım da normalde göndermiştim.
Tamam onu çıkardın değil mi tekrar?
Çıkardım.
Tamam.
Dersin başına bir şey demiştim. Tam boş olasın.
Ha, unutma sakın. Unutursan da videoya çektim. Burada tekrar dinleyebilirsin. Sonra sen anlamadan anlamadım. Ben de neyse uzatmayayım.
Sesler.
Ya bunu niye şey yapalım? Osman. Bol ver.
Telefon flaşımı alayım.
Evet,
Çıkınca bu tarafa gel. Aynen ya. Ne bileyim orası boş olunca direkt o zaman çok güzel. Kurumuş. Zekice. Teşekkür ederim. Burada kalem var. Aa, burada kalem var. O hayır.
Başkalarına yeni imza atmıyorsunuz değil mi?
Hocam ben imza atayım mı? Zaten belli.
Başkasının yerine mi?
Yok kendi.
Niye atmadın derste? Geç mi geldin?
Yani yok özel öğrenci olarak.
Evet. Bak, hemen yaz at.
Numaram yok. Numara yok.
Numara idare ederiz ya. Numara. Yok bir numarası numara.
Hocam özel öğrenci olunca da atıyorum değil mi?
Özellikle özel öğrenci olarak atman lazım ki ben sana not verebileyim.
Tamam.
İsmin olması lazım orada. Var mı ismin?
Burada yok hocam.
Öyleyse ben de özel öğrenci olarak kaydoldum diye hala isim burada çıkmıyor. Bu nasıl iştir?
Ben yine kontrol
Söyle,
edeyim ama
nasıl
tamam.
üniversitede? Yok orada çıkmaz özel öğrenci ikinci sınıfta. Bilmiyorum ki. Sen arka tarafa ekle onu ya.
Tamam.
Yok şuraya ekle, buraya ekle. Yüksek lisansların yanına ekle.
Hocam devamsızlıkla alakalı alttan Allah'ın için bir şey söylediniz ama ben tam anlayamadım orayı. Yani
Yönetmelik diyor ki bir öğrenci devam etmek zorunda değildir diyor eğer daha önceden kaldıysa. F'le kaldıysa. Neyle kaldın?
tamam teşekkür ederim.
Değildir. Ama gelmeyenlerin çoğunda kaldığını biliyorum.
Peki hocam eski yeni
Ben-
yönetmelik fark ediyor mu acaba?
Eskide de aynısıydı, yenisi de aynı.
Ben Cuma günü dahil olamayacağım da çalıştığım için. Onun için söylemek istiyorum.
Ben sana söylüyorum, istatistik diyor ki gelen öğrenciler çok daha fazla geçiyorlar. Hepsi geçtiğini söyleyemeyeceğim. Ya da gelmeyenlerin hepsinin kaldığını söyleyemeyeceğim. O durum bu.
Ama genelde ondan sonra oradan aldığımız dersleri açılan dersleri geçen dönem aldığımız bu şekilde dersi
Tamam, son detaylı olarak. Ben söylemiştim, ben biliyorum. Fakat tarihte boş
Yedek tutanımı yoksa yedek tutanımı yoksa orada
direkt proje Allah ben sana söyleyeyim bana şey dedi ben şimdi orada şey yapacağız. Bana referans alacağım. Ben referans alacağım.
Gel. Ben kalemimi bir yere mi koydum ki ya? Burcu'nun yanına geçiyorum.
kaydediyor mu?
Acelem var, bir çıksın hemen. Yok, hiçbir yapmadım. Bu yaprağı dönsek olacak şekilde. Ya belki birkaç kişi gidince biraz daha indirimli yaparım. Ya hoca gördüğün gibi ilk hafta başlıyor, muhtemelen cuma günü 50 sayfasını bitirmiş olacak falan, sonra bir sıkıntı yaşıyor.
Ortalama yükselttim geçen
CZ'yle geçti. Helal olsun. Bir CZ olarak.
Önerinden 40 aldım. Nasıl olduğunu bilmiyorum. Kaplan olarak tam. Ama bilim metodolojisinden kaldı.
Ben de 2 kere kaldım.
Sonra bütünlemeye girip yükselttim. Ne yaptım? FF'e çekti, onu da BA'ya çekti. Çünkü filmler listesi olmuş.
Ben de ET'yle kaldım.
Üzücüydü birazcık yani. Her şeyden geçtim, onun bütüne geldim yani. Öğrendim ben. Bir gün izle ama öğrendim. 100 aldım sonra sınavda herhalde. 100 alınca BA geliyor. 100 aldım herhalde. Al ya, ben canım yüksek geçerse. Ya ama bak yaparız, bir dönem yaparız onu da. Şimdi biriler sonra bir çakalım yükselsin de. Al işte.
Okay, let's continue. Can I change my resolution? This doesn't look right. Okay, let's continue. What did I say? I said that extends and or virtualizes the underlying machine. One way to extend the underlying machine is the virtual memory. The other one is there are two very important things in a computer hardware. One is the memory, the other one is the CPU. Okay, we need to extend or virtualize the CPU so that each user of the system can think that he or she has her own CPU. Okay, so memory virtualization, virtual memory is important. Okay, as important as virtual memory, virtual CPUs are important too. In your hardware, you could have just a single CPU, but here at this level, maybe there are hundreds of programs being run. Okay, and each program thinks that it has its own CPU. So it's the task of the operating system to virtualize and extend a single CPU so that I can write these kind of programs. I write my program and I think that the CPU belongs to me, the memory belongs to me. I don't share it with anybody else, and my job is very, very simple. This is what we mean by extending or virtualizing the underlying machine. And the same thing with the disk. Okay, as a user, I think that the whole disk belongs to me, and I write my files and I read it. And in fact, I am sharing it with many other people. Even on this small computer, how many programs do I run here? When I open the task manager, as you see, there are literally hundreds of processes being run, right? And each has a different task to do, and they are all run on a single CPU. Okay, I don't have more than one CPU. Well, I think I have a few cores, but again, even if I had 4 CPUs, it is not enough for all of these processes. So the operating system has to virtualize or extend the underlying machine for me. So that's one definition of the operating system. It abstracts the computer hardware through the interfaces, and using these interfaces I use my computer. And the second part of the definition of the operating system is the management of the resources, and I will talk about this in a few minutes. Let's go back and let's talk about this abstraction thing. Okay, this is my hardware, my CPU, my memory, my network cards, my desks, the mechanical desks or the solid state drives, etc. This is my hardware, and on top of it I have my operating system, a piece of code, very large complicated piece of code, but it's a software. And on top of it I have my compilers, I have my shells, and I have my graphical shells, and etc. Okay, so these are the user programs, and this operating system layer, it sits between the applications and the hardware. Okay, it sits between these two layers, and it abstracts the hardware. The writers of these programs, they don't have to know about the hardware. It provides protection. What do I mean by providing protection? Provides protection.
Accessibility to some specific data.
Inaccessibility to some specific what?
Some data related to the operating system.
If I don't have privilege to access that data, then I shouldn't, because on the same operating system, there might be more than one user, and their data should be protected. Yes. What else?
Switching kernel mode to user mode maybe.
What do you mean?
If more than one program uses the same memory locations, preventing each other from crashing to other one.
Yeah. So if more than one program, so I should protect the data from one user, from one program to another program. That's a good thing. But you said that kernel mode or
user mode, kernel mode, and user mode.
So what do you mean? Because I didn't talk about user mode and the kernel mode.
In user mode, we are not allowed to use. We are not allowed to have all the accessibility for
Yes.
code, CPU or memory. In user mode, we are not allowed to do some sort of serious things.
Yeah, hardware related stuff. One about this protection, I should protect my data from the other users. One thing. The other thing is that the users, as a programmer, let's say I write my program. Its name is a.out. Okay, it works here. This a.out should not have privilege to access the hardware directly. Okay, a.out should not be able to, let's say, go to a memory location and change it, any memory location and change it. It should be protected by the operating system and by the hardware. So this providing protection has many faces. One of them is protection between the users. The other one is protecting the system resources from the unauthorized users, and it manages the resources. What do I mean by that? If there are, how many programs am I running on this computer? On this one, hundreds of them, right? Each one is trying to access the disk, okay, my solid state drive. If I don't manage their accesses, okay, some of them, for example, one program takes the disk and it doesn't give it to anybody else. It keeps using it. Or if one program takes the CPU, okay, and it doesn't give another program any opportunity to use the CPU, so the other programs cannot use it. So somebody has to manage all of these resources so that the usage is fair and usage is efficient. So that's the task of the operating system. Abstracts the hardware, provides protection, and it manages the resources. Again, the definition of operating system. And we will keep talking about this all the time. When we discuss virtual memory, okay, we will talk about providing protection. How do we protect the memory from the other users or from the unauthorized use? When we talk about virtual memory, we say that how do we use the memory in an efficient way so that we don't have any unusable memory slots, or which is called whenever we come to that point, we will talk about it. And unused memory spaces is an important problem, fragmentation. Okay, let's talk about this abstraction thing. OS as hardware abstraction. Okay, in my computer I have one or more processors, main memory, disk, printers, and various input-output devices. Okay, and as I said, I need this layer of software. If I don't have this layer of software, my programs has to manage all of these by themselves. That means that whoever is writing those programs, okay, should be knowledgeable about processors, main memory, disks, printers, and various input-output devices. Okay, and this is a very serious amount of knowledge, and nobody has this kind of knowledge nowadays because it's a very complicated thing. So instead, operating system handles those kind of tasks for me. Okay, hardware, operating system, my user interface program, and my what is a user interface program? User interface program.
Shell.
Our shell, for example, our C shell. If I am using a Unix style, where is my, yeah. Say this is my shell, this is my, I guess, this is TC shell, no, this is bash. Okay, this is my shell, and this is an interface. I give commands and it gives me results back. Okay, so this is a text-based shell. The one that I'm using right now with this mouse clicks and my fingers and etc. This is a graphical user interface GUI. Okay, and it is provided by the Windows. Okay, so every operating system nowadays has this kind of C shell, or X11 is the graphical user interface for the Unix operating system. And using these, on top of them, I have my programs, my music player, email reader, and web browser. Okay, see, there are two modes in here, user mode and kernel mode. The CPU can run in two modes. In kernel mode, if you are running your CPU in kernel mode, you can do anything you like. Okay, you are allowed to send signals to your IO devices, read them, modify them, do whatever you want. So that's why you need to be very, very careful about in the kernel mode, because any mistake you make might cause a system crash. Okay, but if you are in the user mode, certain things are not allowed. For example, I like to read this byte from this sector of the disk. No, you are not allowed to do that, because only operating system can do that. So in user mode, you are restricted. In kernel mode, you are not restricted. But only operating system operates in the kernel mode. As a regular user, as a regular programmer, the programs that I am writing, they will run in the user mode. Okay, only the operating system is allowed to run in the kernel mode. Of course, both user mode and kernel mode, they are both software, and this part is a special kind of software, and it is written by the operating system designers, such as Microsoft or whoever is developing your Ubuntu distribution. Okay, and we write our programs are here. Okay, on there. So we are in the user mode. We are restricted. We can't do anything we like. Okay, if we try to do them, okay, we get either segmentation fault. That means that you are trying to reach a memory location that does not belong to you, or you have some other core dumps saying that the operating system says that this program performed an illegal action and I will terminate it. Okay, nowadays that's the structure, and we are talking about, again, abstraction. With this kind of abstraction, my program writing is better and safer. Okay, let's talk about the second part. Remember, the first part was definition of operating system, abstraction mechanism as a operating system. Let's talk about this managing stuff. Managing, okay. Operating system manages the resources. It does. I mean, its only job is not abstracting the hardware. Also, it manages the software, hardware. We have processors, memory, timers, disks, mice, network interfaces. What is mice? Our pointing devices, like the trackpad or the mouse or whatever you have, etc. How about timers? What are timers? there are special kind of hardware that keeps that keep the clock. Okay, it tells us the time of the day. One. The other one is that I am a process. Okay, I will go sleep for 100 milliseconds. After 100 milliseconds, wake me up. Okay, you can set up these kind of timers, and we use this all the time. We use this all the time. And they are called timers, and operating system uses this all the time, because operating system says that this program will run for 100 milliseconds. After 100 milliseconds, I am setting up a timer. Interrupt this program. You are telling this to the hardware, and I will take the control. So operating system says that I will let this program run 100 milliseconds. After 100 milliseconds, the timer will cause an interrupt, and everybody knows what an interrupt is from organization courses, and I will take the control. So timers are very important. They have to be managed, and of course, as a regular user, I don't have access to timers freely. Of course, I can say that in 100 milliseconds I will wake up. That's what you can say, but you may not say that as a regular user. As a regular user, you may not say that stop the other process in 100 milliseconds. Again, printers and displays. Printers are so important. If the printers are shared by 50 people, 50 different people, you have to manage it, right? Who is going to use the printer first? Who is going to use how many minutes and how much time, and how the printer queues look like, etc. Displays. What did I say? On this machine, I have hundreds of programs, and they are using the same display, right? They are using the same display. So it has to be managed too, okay? Basically, managing the resources, it allows multiple users and programs to share the resources and coordinates the sharing. Without this management stuff, the computer is too complicated to work on. I mean, even with the help of the operating system, we have enough difficulties to write programs. Without the operating system help, it would be very, very difficult. Okay, so it would be like the first generation of computers, they didn't have the operating systems. Okay, that's why they were very difficult to use. But we didn't have many computers then. We didn't have many computers engineers then. Maybe there were at most a few in the United States, maybe a few in the Europe, and that was it. There are a total of maybe at most 10 or 20 computers in the whole world. So specialized people, specialized scientists worked on them. Later, when the computers became cheaper and more common, since we understand that they are very useful, we said that we need people to use them, and I cannot train them like that, and they need to be more efficient. Then we started having operating system helper programs to abstract the hardware, helper programs to manage the resources. Okay, some people say that operating systems are like governments. Okay, like the Turkish government, we have a government. What is the task of the government? Manage the resources. Okay, as a citizen of this country, I own some properties. Okay, I get to use some of the resources of this country, like the roads and the water and the electricity and etc. Right? So the government is responsible for managing all of that stuff. If somebody says that this road belongs to me and I will not follow my lane, I will make speed and etc., the government will come to you and say that no, you can't do that. You have to share this road with other people. Otherwise, I mean, how are you gonna manage all these 80 million people in a land like this? Okay, so the government manages it. Also, government sometimes makes things simpler for me. For example, I cannot produce electricity for my home. Okay, the government does that for me. All I do is I just pay a amount every month to the government, and it does that for me, and it does this abstraction for me too. And but maybe I didn't mention this before. I kept saying that operating system is a piece of code, right? It's a software. Since it's a software, it has to work on the hardware. So it uses some memory, and it uses some CPU, it uses some disk space, etc. So operating system uses some part of the system resources too. Okay, if your operating system is very robust, if it is very reliable, it keeps all your information very, very secure, but it uses most of the CPU percentage, most of the disk space. And if you can't do anything because your operating system is too large, then that's not a very good operating system, because I mean, it doesn't matter if it's a reliable operating system or very robust operating system, very good operating system. It doesn't let me do anything because it uses all the resources. Governments are the same thing too. Okay, if you are a government, okay, you provide healthcare, you provide justice, you provide education, you provide communication, etc. But the government is so big, so powerful, it hires maybe 40 million people. That means that government is using most of the resources of the country. So I can't, as a citizen, I can't start my own business because the government doesn't let me do that, because government is using all the roads. Okay, the government using all the electricity, etc. So we have to be careful about it. Operating systems are nice, but they cannot be very, very big. They cannot be using all the resources of the computer. That's why, as an operating system designer, I should be very careful about those. Of course, I should do the abstraction, I should do the management, but I should do this in a efficient way. Otherwise, if the operating system on this computer uses, I think for this one, mine, the Android operating system uses 20 or 30% of the battery power every day. More than that, I mean, I don't like it. 30% is gone for nothing. I am not using it. The Android operating system uses it. But if the Android system doesn't use it, then this machine becomes unusable, because there are many applications, apps that I am running on top of it. If it uses a little bit more, like 50 or 60% of the battery power, then this becomes unusable, because in a few hours this will be out of battery and this is not a useful device anymore. So as the designers of the Android system, they have to be very careful about how much resource they are using, how much battery they are using, how much CPU they are using, how much memory they are using. And as the governments, I should do the same thing too. Okay, I should provide justice, I should provide education and healthcare and etc. But I should not be using most of the resources of the whole country. Otherwise, my private students will have difficult time to build their businesses and live their nice lives. Okay, any questions? Okay, you started talking about justice and I keep talking justice today. Okay, this is a directly picture from the book. I don't like this picture because it says that this hardware is ugly and the interface is nice. I don't think that this is nicer than this one. So the idea is nice, but the drawing is not. This is not an ugly animal. This is a perfectly good frog, right? I don't know. Yeah, I mean, this is not more beautiful than this one. Both of them are beautiful. Anyway, other than that, that's a nice picture. Okay, operating system as a resource manager allows multiple programs to run at the same time. Okay, and one of the programs is always an operating system. If you have a single CPU in your hardware, you will keep seeing this many times. Okay, hardware, and let's say you have a single CPU. Okay, and on top of operating system you have this is OS, these are your programs. If you have a single CPU, that means that only one program can run on that at a given time. So it will be either operating system or the user programs. If the operating system is running on the CPU, it runs in the kernel mode. Okay. If the program is running on the CPU, it runs in the user mode. Okay. So this is given. There is no other way of doing this. You may say that, okay, nowadays I have many CPUs. Like on this computer, I think I have 4 cores or something. I don't know. How do I get that? By doing this. Open it. Restore. Where? Okay. Performance. How do I know that? How many CPUs do I have? I think I have. Where does it say 2 cores? On the right.
Ya söyleyeyim biraz aşağıda. Aşağı ineyim önce. Orada alt alta şeyler yazıyor.
I have 2 cores here, yeah. That means that I have kind of 2 CPUs. Yeah, 2 CPUs, but it didn't have to be that way. I mean, even if you have 4 CPUs in your system or 16 CPUs in your system, one of them doesn't have to be the program, doesn't have to be the operating system. Let's say I have a single CPU, okay, and either operating system or the programs are running. Operating system is written by the professionals, very careful people, very smart people, and I assume that it doesn't do any harmful stuff. But programs are written by ordinary people, by mistake or intentionally. They might be bad programs. Oh yeah, okay. If a program makes a mistake while they are running on the CPU, try to access some memory location that doesn't belong to that program, that hardware and will stop it from doing so because it runs in the protected mode. How about this case? Let's say my program P1 is working on the CPU and it is in an infinite loop. It just tries to in a loop like this while 1, and it does this. It keeps using the CPU and it doesn't let it go. That means that operating system will not run without that program ends, or that program says that operating system, I am done. So how are we gonna solve this problem? What is your solution? Operating system doesn't have the power to say that this program has run enough, just stop it, because operating system is not running. Only the program is running. So the program has the control of the CPU and the memory and everything. Somebody says something.
Interruption, timer.
What do you mean? What do you mean timer? Yeah.
Timer decides this program use resources enough and stops.
Before this program starts running, yes. Before this program starts running, operating system has the power of has the CPU. Operating system says that okay, I have run enough. I will let one of the programs run. It will be a program number 1, but it sets up the timer to 100 milliseconds. Let's say, okay. In 100 milliseconds, if the program says that I am done, it is done. If it is not done, that timer will create a interrupt, and interrupts are by the hardware. That interrupt will stop this program and it will let the operating system run. Okay, so the timers are very important. Without the timers, without these kind of timer-based interrupts, a program can take the CPU and use it forever, and the rest of the system will starve because they don't get the CPU. That includes the operating system, and that used to be the case, by the way, in 1980s or beginning of 1990s. Many computer systems didn't have the timers, and operating system, if the program starts running CPU, starts using the CPU and doesn't let the CPU go, the whole program suspends and doesn't do anything else. Even today, sometimes your operating system doesn't respond, right? You don't get any response. That's because somebody is using the CPU and other system resources, and that thing is very important. I cannot interrupt it. Okay, interrupt doesn't work on that thing because maybe it's part of the operating system. Yes.
Is the time decided by the operating system? Or
Sure.
by the software?
Yeah. Setting the timer is only allowed by the operating system.
What if the program actually needs more time launched?
Then after 100 milliseconds, what is the answer? That's a very good question. If the program needs like a second, 1000 milliseconds, and after 100 milliseconds the program is stopped, what happens? Yes.
The things required to done for this process would be done in another interval. The CPU handles
Yeah. Exactly.
stuff, and
Mhm.
divides the medium terms is extra.
It is the responsibility of the operating system to make sure that all the programs complete, okay? But 100 milliseconds is not enough. So the timer stopped the process number 1. Operating system run again. It did its stuff. And after it is done, operating system will say that, okay, whose turn is it now? Program 1 or program 2 or program 3? Okay? If it is the program 1 now, program 1 can start working again from wherever it left off. But the programmer of the program 1 doesn't know that its program has stopped. Because all the program 1 is doing is executing its instructions. Okay? So that's the responsibility of the operating system to use the CPU, to divide the CPU time share the CPU time between the operating system and the user programs. Okay? So, but the programs doesn't know. The programs think that they have their own CPUs. Okay? They don't know that they are interrupted. Okay? All they do is they execute their instructions one after the other. It's the responsibility of the operating system when they interrupted to save their data to some nice place, which is called the process table. And when they start again, they load their data from that process table too. Okay? So that's a good point. You should ask. If you didn't ask that question, I don't have any idea that you have problems with that issue. Okay? You ask me a question. Operating system has they say it's a complicated system, but ideas are very, very simple, and sometimes we have some difficulties to teach you about the simple stuff. So you should if you think that something doesn't make any sense, you should immediately ask it. Okay? Don't let it go to the next course. Okay? Yes.
I don't understand why the infinite loop is problem in this case. You said.
Well, it's not a problem because we solved it. Over there they said that there are interrupts, because if it's an infinite loop, if it's an infinite loop, okay, somebody has written bad code, this program run until infinity, okay. If it's an infinite loop and if this program doesn't release the CPU, that means that rest of the operating system and the rest of the system will not get their fair time, okay. So by using this interrupt mechanism and the timer mechanism, I say that, okay, I will let this run forever, but while it is running, I will stop this time to time. I will let the other programs do their work, okay, and I will do this in turn, okay. So let's say if I have let's say program number 1, P number 2, and P number 3. So this will run 100 milliseconds, then this will run 100 milliseconds, then this will run 100 milliseconds. But when my CPU switches from process 1 to process 2, it doesn't do it automatically. First operating system runs, then this. Operating system, then this. So there is no direct connection between them. Between the process switches or the program switches, operating system has to run definitely. So it is always very important. It is always in the memory. It always has the control. Of course, it needs lots of help from the hardware. Why? Because my CPU has to provide two modes of operation: user mode and the kernel mode. Okay, this one and this one and this one, they are in the user mode, and this one and this one in the kernel mode. If the hardware doesn't let me choose the kernel mode or the user mode, if the hardware has only one mode, that is the kernel mode, then my programs can't do anything they want. That's a bad thing. They as soon as my program starts, P1 starts running, they say that, okay, cancel all the interrupts. Okay, cancel all the interrupts. I will run the CPU forever. If it does that, then my system crashes. For some embedded systems, this is possible. Very simple systems, very, very simple systems. By embedded systems, I mean systems like on this one, there is an embedded system. On this one, there is another embedded system. On your credit card, there is a computer and there is an embedded system. Okay? On your credit cards, did you know this? On your credit cards, there is a computer and there is an operating system and it's an embedded system. Those are very, very small, very, very weak operating systems and the computers. They don't have privileged mode or they don't have kernel mode, user mode, because that makes the hardware very complicated. So those kind of systems, operating systems, they are the programs has to be written very, very carefully for those kind of systems. But ordinary users doesn't write programs for those kind of systems anyway. I cannot upload a program for this one. I am not allowed to because I don't have the API. I don't have the interface, or for this one I don't have the interface, but somebody has it. Okay, good.
Do we have a power source on our credit cards?
Do we have what?
A power source?
You know it doesn't work when you insert it to the machine, that post machine. It gets the power from that, okay, and the computer boots up, and all it does it gets the pin number from you, and it verifies it, and if it says okay, then they let you take the your purchase. Otherwise, they call the police. Okay, so though your HGS passes that we use for the freeways, HGS kartlar var ya arabalar taktığımız. They have computers too, okay? They have their operating system. But how do I boot it? They are booted using the electromagnetic waves. That small amount of power is enough for them. So when you go through the boots, okay, they are booted. Operating system initializes, and it relays its ID number to the station there, and you get charged your number. So when the 0.2 seconds that you spend while going through those boots, your computer boots up, your program runs, and your computer shuts off, and all the electricity, the power comes from the electromagnetic waves. Okay. So let's move on. Did I forget anything? Okay. Allows multiple programs to run at the same time. This is the structure, and this is how it does it. And it manages and protects the memory, I/O devices, and other resources, and the CPU too, of course. And it uses this technique a lot, multiplexing or sharing. I share my memory. This is my memory. How does the memory look like? It starts from address number 0 to 2 to the power 30. Okay. So let's say this is how I share it. This is the operating system part. This is the process number 1. This is OS. This is the process number 2. So I shared it. So I shared it in space. I share my memory in space. But how do I share my CPU? I cannot share my CPU in space. I share my CPU in time. Okay. So this multiplexing or sharing is done in two ways: time multiplexing or space multiplication. Multiplexing. Okay. Of course, when you do the sharing, I should be fair. Okay. I should pay attention to protection, and it is all the task of the CPU. Okay. If one program uses the 80% of the CPU time, that's not going to be fair. But if the operating system tries to use maybe 60% of the time from time to time, it might be required, it might be needed. So the fairness, protection, efficiency, robustness, security, these are all the issues that operating system has to be careful about. That's why they become more complicated. Any questions? Let me move on. Okay. When I say operating system, there are, as I said, there are many ways to look at the operating system. One way is wide view, the other one is the narrow definition. Okay. When I say wide view, Windows, Linux, Mac, OS X are operating systems, and these are complicated operating systems, very powerful operating systems. With the Windows, you have your system programs, system libraries, servers, shells, GUI, backup systems, and etc. Okay. So when I say an operating system, when you buy a Windows release, okay, it comes on a CD or DVD on a USB. Whatever you download, the whole thing is the operating system. You may say that operating system is this, that's the wide view. But the narrow definition is this: OS often equated with the kernel. Whatever is running in the kernel mode, it is called the operating system. Okay. Not all parts of the Windows executables run in the kernel mode. For example, in Linux, your GUI, graphical user interface, it runs in the user mode. Okay, so for that one, it is not part of the narrow definition of the operating system. It is not in the kernel mode. It is in the user mode. Okay, for Windows, for example, backup systems, they run in the user mode. For Windows, for example, this Explorer, this one, okay, this one runs in the user mode. This is not part of the narrow definition of the operating system because it doesn't run in the kernel mode. Okay, so in this class, when you say operating system, we usually mean the narrow definition. Whatever runs in the kernel, it's operating system for us. Okay, but for most people, for ordinary people, when I say Windows, okay, it is the wide view that counts. Okay, because when I say, they think about whatever they pay for. Okay, they pay $100, $200 to the Microsoft, and they get a software. They call that software operating system. But for us, operating system designers, we usually deal with the problems and issues with the kernel mode. Okay, that's the most important part. Again, I keep talking about maybe more than an hour. I am still trying to define you what an operating system is. Okay, how we look at it and how we design it, what kind of views we have on the operating system, and this will go on again. And I skip some of the details, and you are supposed to look at those in the book. And after that, it's not enough. We have to look at the history of the operating. This is very important. Okay, history is very important because history defines why we are doing some of the things today. Okay, as a society, okay, composed of human beings, or as a computer scientist that work on the operating systems, you should always know the history. Okay, history of your country, history of your university, your city, or your operating system, or your programming language. That's important because some of the decisions made during some time ago is very important. That's affecting how we are working today. That's why I need to look at the history of the operating system. That will give you very good definitions of some of the concepts. Okay, and these are the main periods of the operating system. They are very parallel with the generations of the computer hardware. Okay, for example, when you took this class 101, CSE 101, that was a very important course, and that book that we read in the course CSE 101, Introduction to Computer Science, Computer Engineering, they talk about the generations of the computers. When they started with the vacuum tubes, okay, operating systems, there were no operating systems then, because the computers were very, very weak. They are not very powerful. They are not powerful. Okay, since they are very weak, they didn't have enough memory space or the CPU time for an operating system. So we didn't have the operating system. Everything has to be done by the operators. Everything has to be done by the scientists or the engineers. Okay, but when the computers started becoming cheaper, I have transistors and the batch systems. Then I started having programming languages and operating systems. Then when they invented this integrated chips, okay, transistors coming together by the millions, by the thousands, then I started talking about multi-programming, time-sharing systems. And Multics was a very important operating system during the 1960s and 70s. Most of the operating system concepts are invented by this operating system. Okay, they invented cloud computing, they invented security, they invented multiplexing and etc. Okay, but they didn't have enough computing power to make it more popular. Unix derives from Multics, and Linux derives from Unix, and Android operating system, I think there are more than 2 billion copies of Android running right now. That's the most common operating system of all. It comes from this root. So we will look at that one, and most of the concepts come from that. Later, when the computers become large-scale integration, become more smaller and cheaper, we started having personal computers, and we have DOS and Windows, etc. Nowadays, we have the mobile computers, very small computers like this one or your watches. These are very small computers, and they have different issues. But when those first started, they ran into the problems of these computers, because the computers were so weak. They didn't have enough power, so their operating systems are not that powerful. When we started working on these cell phones, okay, their CPUs were not powerful. They didn't have enough memory, so they were trying to solve the same problem as these computers. Okay, when I started programming these kind of computers, very cheap and unpowerful computers, again, we keep going back to 1950s and 1960s and solve the same problem with the new type of hardware, and we will see this over and over and again. And in fact they give it a name. Okay, I think I will talk about that later. Anyway, so in the operating system world, we keep solving the same problem over and over again with the new invented hardware. So that's why it is important to know the history of the operating system, so that we know what we are talking about. Okay, that's it for today. I will see you on Friday, and by Friday I hope we will resolve this Moodle or the ödev kutusu problem. And other than that, that's it for today. Thanks.